In this video, we're going to take a look at multiplying a monomial into a polynomial through the distributive property. So we have an example here where we have a monomial multiplying into a binomial. So if you recall the distributive property says you take your first term and you multiply it to both terms, and you use the signs to multiply. So if we're taking this and going to multiply using the distributive property, 2x times 3x, if we remember our properties of exponents, when you multiply powers with the same base, you add exponents. So we're going to end up with an x squared. But what do you do with the coefficients? Well, you just multiply. So 2 times 3, that's going to be 6. So we're going to get 6x squared for the first term. And then for our second term, you just say 2x times positive 1. So since this doesn't have x to any power, the x that we have here is just going to kind of tag along for the ride. And you multiply the coefficient with the constant. So 2 times 1, that's 2. And then we're going to end up with x. So we get 6x squared plus 2x. And if you recall from our classifying, this would be a binomial and it would be a quadratic binomial. Now, how do we deal with something that has more terms? So now we have a monomial into a trinomial. We do the exact same thing. So we just have to consider multiplying this term into all three terms. Now there's also this negative here that we have to account for. So you need to make sure that when you're multiplying, this negative is going to change the signs of each term respectively. So let's take the negative 4y squared and distribute it through. So negative 4y squared times this 5y to the fourth. So negative 4 times 5, that's negative 20. And then we have y squared and y to the fourth. So when you multiply powers with the same base, you add the exponents. So 2 plus 4, that's 6. So we have 20y to the sixth. That's our first term. Whoops, sorry about that. And our second term, negative 4 times a negative 3. So a negative times a negative is going to be positive. 4 times 3, that's 12. So we have y squared and y squared. So that's going to give me y to the fourth in adding the exponents. And then negative 4y squared times 2, this constant. So again, there's no y to any power, so we're just going to multiply the constant with the coefficient. So negative 4 times 2, that's negative 8. And then our y squared tags along for the ride through the multiplication. So this would be a trinomial, and we'd call this a 6th degree trinomial. Let's take a look at a couple more, and then I'll have you try some of these on your own. So we have this here. Now this one's a little different because we have a monomial multiplying into a binomial, and then another monomial into a binomial, and they're being subtracted. So what we're going to do in this situation is we're going to deal with each of them on an individual basis, and then we're going to combine everything with like terms. So let's deal with this first monomial and binomial. So I'm going to take the 4b, and I'm going to distribute it into our two terms there. So it only gets distributed into these two terms because those are the only two terms with the parentheses. And that's what's telling me to multiply. So this minus 3 here is basically breaking this into two different parts. So we're going to have to deal with this part later. So 4b times 5b squared. The 4 and the 5 multiply to be 20. B and b squared when we multiply. Remember, this b really has a power of 1. So 1 times, or sorry, when you multiply powers with the same base, you add the exponent. So 1 plus 2 is 3. So we get b to the third. And then we have 4b to the first plus or times b, right? So we're going to distribute now to the second term. So again, when there is no exponent written and there's no coefficient written, those are implied to be 1s. So we have 1b to the first. So when multiplying, we're going to get 4 times 1, that's going to be 4, and they're both positive, so it'll be positive. And then b to the first and b to the first, you add those exponents to give me b squared. So this takes care of those first terms. So now let's deal with this second part. I'll do this in a different color. I'll do this in green. So again, we have this negative here. So we have to account for the negative when we're distributing. So we're going to take the negative 3 and distribute it to both of these terms. So negative 3 times b squared. Again, this has an implied coefficient of 1. So negative 3 times 1, that's negative 3. This doesn't have b to any power, so it's going to take whatever the exponent is here. So we're going to get b squared. Sorry, that's pretty bad. So b squared. And then negative 3 times negative 5. Those are two constants. And so we're just going to get 15 there. Now we need to combine like terms. So if you remember, like terms are any terms that have the exact same variable composition. So b to the third, are there any other b to the thirds in this expression? No. So that's going to stay 20b to the third. We have a b squared. Is there anything else with a b squared? Well, yeah, we have this negative 3b squared here. So in order to add like terms, they have to have the exact same variable composition. The variables will remain the same, and you just add or subtract whatever your coefficients are. So 4, positive 4 minus 3 is just 1. So we're just going to end up with a plus 1b squared or plus b squared. And then the 15 has no like terms, so we can just say plus 15. And that would be our cubic trinomial. How do we deal with a situation like this? So we have a trinomial now multiplying a monomial. There's two different ways that we can approach this. We can just kind of distribute from the back, or we can, because this is multiplication has the commutative property, I could just take this whole negative 7n, move it to the front, and then distribute through that way. Right, so we can think of it as this, or we could think of it in this way and say negative 7n times the 3n squared minus 8n minus 1. The reason we can do this is because the commutative property, right? The commutative property says if you switch the order in multiplication, you have the same value. Like 3 times 5 is 15, the same as 5 times 3 is 15. So you really have a choice. It doesn't really matter which approach you take. Since I rewrote it, I'll just use this one here. So I would take the negative 7n and multiply it in. And if I was going the other way, basically I would just be taking this term and multiplying the first term first. So that's kind of the approach that we would take in this. So negative 7n times 3n squared. So multiply your coefficients. Negative 7 times 3, that's negative 21. This is an n to the first. So n to the first and n squared is going to give me n to the third because, again, we add the exponents. Distribute this here, negative 7n times negative 8n. So the negative 7 times negative 8, that's positive 56. N to the first and n to the first, 1 plus 1 is 2. So we get n squared. Negative 7n to the first and negative 1. So negative 7 times negative 1, that's going to be positive 7. This n to the first doesn't have anything to multiply with, so we're just going to get n to the first. You could also think about it, and I don't need to write to the first. You could think about this, right, as negative 1 times x to the 0, because again, x to the 0 is 1. So if we were adding the exponents there, 1 plus 0 would still be 1, so that's why that n stays there. And that would be our polynomial there. Again, it's a cubic trinomial. So that's kind of the basic idea in distributing a monomial into a polynomial. So I have two problems here that I want you guys to try on your own. So if you would, go ahead and try and work through these two problems, and I will come back and we can talk about them once you're done. So if you would, please pause the video, try and do these two problems on your own, and we'll come together and talk about them when you're done. Good luck. Okay, so let's bring it back together for this first one. So we're taking this 2x and we have to multiply it through to all three terms in this polynomial. So the 2x times the x to the third, this has an implied 1 here. So the 2 times the 1 is going to give me 2. X, this is an x to the first, so this has an implied power of 1 as well. So x to the first and x to the third, adding exponents gives me x to the fourth. 2 times negative 6, that's going to be negative 12. Again, x to the first and x squared, adding exponents gives me x to the third. 2 times 5, that's 10. This x to the first is going to tag along for the ride. So we should get 2x to the fourth minus 12x cubed plus 10x. Let's go ahead and try and work through this one. So go ahead and pause the video again and try and work through this one on your own. Okay. So for this problem, I chose to leave this monomial at the end. In the last one, I moved it because of the commutative property, and I wanted to just take it and distribute it through to all of my terms. So the 4x squared is going to multiply this 3x to the fifth, so 4 times 3 is 12. X squared and x to the fifth, add exponents when you have powers with the same base. 4 and negative 7, that's negative 28. X squared and x squared, 2 plus 2 is 4. 4 times 1, that's going to be 4. Again, this doesn't have x to any power. This is like x to the 0. So 0 plus 2 would be 2. And that would be our polynomial. This would be a 7th degree trinomial. And this would be a 4th degree trinomial.